Digitisation is reshaping how utilities protect and control their networks. That's on the agenda on today's episode.
This is Powering the Future, a podcast series brought to you by Smart Grid Forums. One planet, one power grid.
Few people understand this evolution better than Peter Hemmer from Grid to Great, who joins me today on the podcast. Okay, hi Peter. Thank you so much for joining us on the podcast today. It's great to have you here.
Hello, Mandana. Thank you for the invite. It's great to be here.
Before we just get into the questions, Peter, it would be great to know a little bit about your background in your organisation, Grid to Great, your personal profile and your priorities in the business.
My background is actually civil engineering and business administration. And I started in the energy business at contractors, so cables and pipes. And I'm working since 2011 at Grid to Great. I came here as a program manager for rollout of substation automation solutions. And nowadays I'm a business development manager.
Great. Okay. So let's start with your work on CPC and SAS sensor. What were some of the biggest lessons that you learned from rolling out these systems at scale?
Development of Grid to Great in the 2004. We developed it together with the Dutch DSO Alliander. It's a CPC solution. So centralized protection and controls was quite disruptive those days. The main idea for developing this solution was to decouple the functionality from the hardware. So the idea was to be able to automate substations, not with the conventional IEDs, but with sensors in the primary installation and the central industrial computer. This also reflects the background of the company. So the company Grid to Great was established in 1983 and stemming from industrial automation, where we had already some experience with, let's say, IoT. And in IoT, sensors, actuators, and central processing is familiar. So we brought this to the substation. The thought behind this was, as I said, the decoupling of hardware and functionality, where the sensors have a much longer lifetime than the traditional IEDs. This was one of the main reasons for developing this. The intelligence was then placed in the central computer. This is what we tested between 2004 and 2010. And as from 2010, we have rolled out 150 installations at Alliander and some 25 installations internationally.
Right, okay. And what have these projects taught you, not just about the technology, but also about interoperability and organizational change?
So interoperability was actually one of the main lessons learned. As we developed it, it was quite proprietary. And that's also why we stopped this product line or needed to stop this product line. And some other takeaways is we saw that whereas you enter the protection functionality within a substation, the market really wants to buy from incumbents. Incumbents have more than 30 years of experience in this mission critical area, and we were a small company from the Netherlands. So that was also one of the learnings. One of the other learnings was that we also support a global 24/7 support organization and asset locomotion or Grid to Great. I didn't mention it earlier, but we changed our name in 2024 from locomotion to Grid to Great. What these projects taught us that interoperability is actually one of the key items. In the time that we rolled out SAS sensor, also IEC 61850 came into play. The SAS sensor solution was a proprietary solution. So that was one of the most important takeaways. Other takeaways were that we also needed to be able to offer global 24/7 support, and that the industry also wants to buy from incumbents. So ABB, Siemens, GE, Schneider, those companies have some 30 years of experience in protection, automation, and control. And this is quite a difficult area to confidence in. So this is one of the learnings, and also very important is the technology adoption. So whereas substation digitalization as a topic in the market has picked up the last years. Some time ago, you also had a podcast about the virtualization of substations. This is a theme that is being picked up. So the industry is now getting more ready for this technology. In the time that we did this sensor, which resembles virtual substations, this was not that common already. Technology adoption is a very important topic.
Right. Okay. So where are things heading? I mean, we're talking about digital a lot, but in the future, software defined. What's the migration path?
As I said, technology adoption is very important. So we really see this migration part where we say, okay, digitization is the core. Having high quality real time data, that's the basis for digitalization. So without digitization, no digitalization. For the introduction of this virtual substation, we see migration paths towards the virtual substation. So the migration path to a virtual substation will, of course, start with the fundament with high quality real-time data. So we see a path of digitization, centralization, and then virtualization. And this path also provides a growing path for this technology adoption.
Could you explain to us what's the significance of that sequence? Why does it matter?
Yeah, it really matters because you cannot change the world in one day. We see a lot of technology sparking. We see a lot of discussion about maybe, as an example, AI being really pressed as the solution for the energy transition. But there's a big gap, let's say, between these new technologies and the systems that are in the substation. So you really should start with the first step, and that, in our view, that's high quality real time data.
Right. Okay. You also say there's no digitalization without digitization. What's the distinction? What's the difference between those two?
Yeah, exactly. So that's the distinction would be the digitalization is of course bigger topic. It's the digitalization of the substation is not only the technology, it's also people that need to be educated with all those new technologies, IT, communication technologies. It's also the organizations that need to adopt. And the digitization is really the analog digital conversion that starts at the source of the analog measurements.
Okay, so once that foundation is in place, what are the key advantages for centralizing protection and control functions?
Once you have this digitization in place, you can start, in our view, to centralize your equipment. So typically, the IEDs are still in the base, like you maybe see on the image behind me, but you can then, with centralization, take out the IEDs and put them maybe in the relay room where the access is much more easy, where you also do not need to get into the primary installation. This way you can much more easily test and integrate your system.
Right, okay. Finally, what does virtualization really unlock for utilities? What are the long term benefits for them?
The long-term benefits is it's probably twofold. So it really has some labor efficiencies, and it brings flexibility. So changing functionality doesn't necessarily mean to change the hardware.
Okay, wonderful. Well, Peter, thank you so much for joining us today and giving us your insights into your latest solutions. We're looking forward to seeing you at SGT 26 in Paris as well, where you'll be there with your team displaying your solutions and being on hand to help utilities assess all the different options. Thank you very much, and we look forward to seeing you next year.
I look forward to it.
Thank you. Join us again next time as we unpack another big topic shaping the future of the power grid. Don't forget to subscribe to our YouTube channel, Smart Grid Forums, and to follow us on LinkedIn. Until then, thanks for watching and listening.
This is Powering the Future, a podcast series brought to you by Smart Grid Forums. One planet, one power grid.